I'm field CTO going on 5 years, and also cloud advocate with Lightbend. Before that, I was in the wild doing IoT use cases in energy, financial, and I rounded it off with a stint as consulting chief architect at Weight Watchers, where they did their digital transformation to actually stay in business. And when I mentioned I had used Cassandra, is because we had a 48 node cluster of Cassandra in that new architecture. So in this role, I've worked with the global, say the global 5,000 to actually solve problems using Akka or Scala or any of the Lightbend technologies, but specifically around scale and being reactive. Today, I'm here to talk to you about our newest offering. It's really, we're putting everything behind this. It's Serverless 2.0. So if you consider Lambda as Serverless 1.0, stateless serverless, we're proposing 2.0 with Akka Serverless, which is really a distributed state model offering that we have. We've been working on this for quite a while now, over a year, probably 2 years, and we've been through an open beta, and we're looking to go into production with actual running customers in the fall, if not a little bit sooner. So without much ado, I think I'll get started on the presentation. So this is, I'll talk a little bit about Akka Serverless, and it'll be in the context of building a wireless mesh application with Akka Serverless. In this case, I have Eero wireless mesh in my home. They're really popular. They work really well. They're actually a customer of ours. I'm very familiar with them and their use cases, so I modeled it out with an Akka Serverless application. And then what I'll be showing you finally is that I have a stand-in device. It's an internet addressable bulb, and that because they don't let you code to these Eero devices for security reasons, this is a pretend Eero device that I've got running in my office. So I'll run through all that with you. Okay. So what is Akka Serverless? So to strictly define it, it is a distributed multi-state model cloud platform providing zero ops experience and polyglot client support, meaning that you've got something that leverages the best of cloud, the best of Kubernetes, the best of Akka, and then letting you code in the language of your choice. If it's a language that that supports GRPC, it's fair game. Some might be community supported, others will be supported by Lightbend itself. You know, as we go forward. Right now, we officially support Java, Scala, JavaScript, but we have other proposed language supports, including Python and TypeScript and Golang and Rust, and the sky's really the limit. So how does Akka Serverless help with this particular IoT use case? So with Akka Serverless, we're API first. We're using protocol buffers that let you define your API and really wring it out, make sure it's good for, has all the correctness before you actually implement any code. And we offer different state models. In this case, I'm using event sourcing because when you're using sort of an IoT digital twin pattern, it's really nice to be able to have introspection into things that have happened, to be able to learn from behaviors over time, to be able to share the data. Events are really great to share. Be able to do simulation, all kinds of things once you've gone down the event sourcing road. But that doesn't mean we don't have other state models. You can do CRUD in Akka Serverless. You can do key value store. You can do replicated entities. So this is just the model I chose. You get that zero ops experience. You don't need to know how to deploy, how things get deployed under the covers, how things are working using Kubernetes or Istio or anything like that. What database is behind it all. You don't have to worry about any of that. Just worry about your business logic. You get theoretical infinite scale. So you code for one thing. I'll be coding for this one IoT device, but there could be millions or billions of them being talked to by the system at any given time. Your code doesn't change at all. So maintaining and deploying your apps is a matter of going into our console, and you could do everything on the console. You could add a new service, tell it where your Docker registry is, look at the logs, look at the different interfaces for your service, all that stuff, without ever having to do any kind of DevOps. There was also equivalent CLI for everything you could do in our UI, so you could integrate it into your build chain. So we're getting that scale automatically. There's elasticity in the system. New pods are added as needed, so you'll start, maybe you're only getting 10 requests per second, and then all of a sudden you're 1,000 requests per second. The system will scale you up automatically and scale you back down when you don't need them. So you get this really great performance and responsiveness and latency and resilience. It matches really well up with things like 5G, where low latency is again going to be this really important thing. We've got this fast superhighway of data, and we surely don't want to be one of the bottlenecks. So we take the onus off the database in real time. So you're really speaking to domain and services in memory at any given time. So the only time we're really hitting the database for your core behaviors is when you're actually instantiating something for the first time, then it's in memory. So let's see something in action. So what I'll be showing you is this digital twin pattern, focusing on the business logic without regard to the infrastructure. You won't think or see or deal with any database, any issues of scale, resilience, availability, concurrency, any of those things. They're not an issue. So this demo will show, I'll show you all the code behind it too, a use case of toggling a Nightlight. So what I've got is I've got a customer location. In this case, it's the Walsh house. And I've got a number of devices in the Walsh house with different attributes. And one of the attributes is whether or not the Nightlight is on, and the ability to toggle the Nightlight on. So in that case, we actually make a call out to the API provided with this LIFX bulb, and perform that function, then sync up the state to reflect whether the light bulb's now on or off. Oh yeah, so you'll see here that in the Akka Serverless world, we've got distributed state management, load balancing. That's like the central core of the system. And that's where the state is actually going to be located at any given time. We're taking care of that for you. We have the state somewhere in memory, or it's being loaded from the disk for the first time. Your application is running in whatever language you're running in. So this wirelessmesh app, I wrote it in Java, but it interfaces with the main line of the system using GRPC and Protobuf. So your code is dealing with the current state, handling commands to do something, like toggle a Nightlight, like add a customer location, and deciding whether it's a valid request or not. And if it is, it's going to create the event, and it's going to toggle Nightlight, things like that. So what we'll do is we just toggle Nightlight, goes into the Akka Serverless world, and it turns it on or off. So what happens under the covers? Under the covers, that call is made, and what happens is we're leaning really heavily on Akka, and Akka has clustered capability, and different things are sharded across the cluster uniformly. So in this case, my customer locations have an arbitrary UUID in this case, and any given customer location, like the digital twin of my home, is living somewhere in that cluster. Akka is really good at knowing where that particular thing is, just as any good sharded system would be. So it quickly locates where that state is going to be. It instantiates or talks to an instantiated instance running on a pod of your code, your business logic, and it'll send the state in, have the business logic run on the state, and do something. And so what'll happen is here's the first thing that happens is the state's located, it's supplied in there. We validate everything, we make sure it's a good request, it's not unfair. And if everything's good, we turn into a fact. We'll actually create an event, which is Nightlight toggled. That will get stored for us. We'll get called back with that event, so we can update the current state once it's safely stored in whatever the database is, and it's turned into a fact. We also side effect at that time, and we actually turn that bulb on or off. Also, you'll see that we have support for eventing, and we're running right now. We're running on on Google Cloud, and we're using Google PubSub. So there's very minimal amount of work you need to do to publish to Google PubSub. I'll be showing you that.
So Sean, at the end of the presentation, will you be telling us how many engineers it takes to screw in the light bulb?
Yes, it will.
And I'm just curious, how do you like, if this is a rat hole, feel free to skip it, but how do you achieve distributed consensus, or is it like a Paxos or like Raft, or like how are you handling that? I'm just curious. You mentioned it was sharded.
So I used to know the answer to this when I was dealing purely in Akka, but now I forget how. But it's a standard mechanism, because I've heard this question before.
Yeah.
So there is cluster gossip. There is close collaboration across the cluster. There's cluster leadership, and I may not be able to say what the algorithm is, but what will happen is each of the nodes in the cluster have a cache of known locations of things in the shard, and so once it's been located the first time, that's cached. So I don't know what the distributed consensus is, though.
Interesting. Yeah, that's curious. Okay, so it's a leader model, but it's like there's caching. Huh, cool. Thanks.
Yeah.
Appreciate it.
Yeah, that's an optimism. That's what's the word?
Optimization.
Optimization. Yeah.
Sorry to interrupt you. I was just curious. Please
That's
continue.
okay. Yeah, it makes me feel like it's in this last couple of years of presentations, it's been a little weird. You can just talk to the screen for a long time without hearing anything. It's really good to hear another voice.
So no doubt. No doubt.
So let's take a look at the code, the deployment and runtime experience, and see some real stuff. All right. So the next thing I'll show you is I will just go into the code now. And could you see my project?
Yes, it's a little on the small side, but
I'll make it bigger in the windows. This is just a standard Maven Java project, and you'll see that we've got source main Java, Proto. That's really the main things we're looking at. And the first thing we do is we do API first. So we'll take a look at the Protobufs. I've got the core syst service Protobuf here. This is my wireless mesh service. And then I've got some other ones that do different things, but I'll just show you this one for now. This is the heart of it. How's that look?
Very clear. Okay. If folks are having trouble seeing it, please chime in the chat, but it looks clear to me.
Okay. So this is just pure Protobufs, and I'm defining the messages that I'll be handling or possibly returning, as well as the GRPC service and its methods that use these messages. So they're just, let me show you the service first. So the service is the wireless mesh service. And these are the things you could do. You could add a customer location, the wall shown. You can remove that customer location. You can activate a new device. So you purchased it at Best Buy. You come in and it gives you a scan code, and you're now activating the device and adding it to your location. You can remove a device, and you can assign a room. So I've previously created one. I'll show you all my gRPC calls. I created one that is my office device, and I've assigned it to office. You can do a get. This is a friendly way of getting current state, just so we could see where we're standing and get a little bit of a trust level in the system. And it's also really helpful when you're doing unit tests. And then there's a toggle Nightlight. So each of these takes a specific message, and then it returns. In this case, it's a get customer location. But in most cases, when you're just doing commands, which are requests to do something to make it an event, possibly, I'm returning empty. It's no promises. It'll either happen if it's successful, or there will be an event to say that it couldn't be done for some reason, and you can pick that up in the back end by subscribing to something. So just one other thing to mention here. So add customer location, you take that message. I'll show you the messages in a sec. And what we're allowed to do here is we could do this option Google API HTTP. And then what this is you get for free when you do this. You provide a URL, and you just put a star in the body. And what it'll do is you automatically get support of JSON and REST over HTTPS. So if you've got developers that don't know gRPC or aren't comfortable yet, front-end developers, they don't need to learn anything new. They could just use RESTful calls. So these messages look a lot like this. It's a really strongly typed interface. Protobufs, when you get used to them, they're actually pretty nice. So this add customer location, you say, what is the ordinal value of each field, 1 through 4, and then what are the data types of them, and what are the names. The naming convention is the lowercase and the underscores with Google Protobuf. This is an important markdown right here, is we're saying that the customer location ID, that is that all important shard ID, that unique ID. So if you do have 1 million or 1 billion of these locations, that's guaranteed to be unique and running once in the cluster somewhere. And so you're telling Akka Serverless that that is your identity. And from here on in, we just got remove customer location, simply takes your customer location ID, activate a new device with a device ID, assigned a room to that device, remove that device, toggle a Nightlight on device, and then that get customer location command, which is really just customer location ID. Also with that get customer location command, there's an option to do like URL parameters. So I could have done it that way here. So instead of having body, I could have just, out of the box, you'll get support for question mark, customer location ID equals something in the URL. So you can support both ways automatically. So that's the service, that's the basic service interface. Once I've created that, I've thought it through. In fact, it's really important that you think this through. I've seen where they're not really well thought through, and what that ends up being is a super big mess in the implementation. But when these are thought through really well, just like domain-driven design, you really think through the behavior of your system, your implementation gets a lot cleaner and looks really good. So I'll give you a look at the implementation of it. So the main nuts and bolts is this customer location entity. Make it a little bigger for you. So what this is this is my running code that is handling the business logic on behalf of any given customer location. In this case, Walsh 6000, I think I called it. What we'll do is we'll say, hey, this is going to be an event source entity, and we're going to give it a unique tag, customer location entity, because if we want to subscribe to that later, we'll need to know that. And then what I've done is I've modeled the state, what the state looks like at any given time. That's modeled in Protobuf also, and also the events that this thing emits is in Protobuf. So I'll show you that real quick too. If I go into my Protobuf domain, you'll see that these are the events. I've actually created these in Protobuf, and it's got all the correct attributes for the kind of event it is. So customer location removed, you'd only really want customer location ID. Why do I have zip code in there? I've got a view that is customer locations by zip code, or I was planning to. If it wasn't in the event, it would be very hard to maintain the view and remove the object from the view once the location is removed. But in any case, these events are really pretty small, only centering around what has actually happened to the customer location, rather than just putting every single attribute every single time, which is not a really a thoughtful event design. And then I mentioned state, device state. So we support snapshotting, which is an event source optimization. So let's just say these IoT messages, you're getting 10,000 per day per device, and you need to instantiate this thing the first time into memory. You don't want to have to replay all these events to build up your current state if there's that many. So what you can do is you can have the system automatically snapshot you from time to time, and you're giving it the current state to be saved on your behalf. And then when you're instantiated, you could be instantiated with your current snapshot, and then plus every event that's happened since. That's pretty much event sourcing 101. That's fully supported here. And here's the message of my customer location state. So if I do get customer location, these are all the fields I'll be showing you. It's really useful in testing and a little bit of just getting comfortable with the system and knowing that stuff's working the way you expect. So given that, that's my entity. And so the first thing you'll see in this entity, it's got a constructor. In that constructor, Akka Serverless is supplying me with my entity ID that we marked in the Protobuf earlier, that's saying it was the Akka Serverless key. And so I'm naming a customer location ID. Make this a little wider. And then what I'm doing is I'm just making my current state in my function, my user function here, which will be running in the code of my choice. And it's going to be setting the state, and it's going to be setting the customer location in addition to whatever else is in the state. When you're instantiating, that's probably the only thing it's going to be, is that one thing. And then what happens is you've got command and event handlers. That's all there is here now. So those protobuf messages coming in, those gRPC calls, they will now be relayed into me with a generated object, Java object in this case, to represent the protobuf message. So add customer location command is given to me. I'm also supplied with a context, which is over here to the right. Command context, so I can actually reply back to Akka Serverless when necessary, like to emit a command. And so I'm being called with that. So my code is now in charge. Now what I'm doing is I'm starting to do some checks. I'm saying, hey, this has already been added. You know, when you first locate an object, and if it doesn't exist yet, the system will actually instantiate it and then replay its events. If it doesn't have any events, it will be instantiated until it passivates. By default, if it's an empty object, like 30 seconds, it'll go away. So in this case, I want to make sure that you're not calling add customer location twice. So I've got a flag in my state saying it's already been added, and I can do a context fail. You'll see that in your browser or in your gRPC call. I'm going to just do a little bit of basic validation if the customer location ID is alphanumeric. But if everything looks good, I'm going to actually construct this event now using the builder pattern. And I'll just say customer location added. This is the ID. This is your access token. This access token is actually corresponds to LIFX. If I want to talk to the bulb programmatically, I need to have one of these tokens per my location. My email for location, my zip code, and then I just build it and emit it. So now I'm done. I don't set anything in my current state now. I don't do anything because this event could fail. This could fail to be, maybe the system has a catastrophic failure. Maybe this function, the node it's running on, becomes unhealthy. And it's as if this event never happened. The last thing you want to do is update your current state as if it did happen. You want to be in a clean state so that event, that command can be sent again, and you could just get things back on the rails. So after that, it's an event handler. So now Akka Serverless will call me back with that customer location added that I just had stored. And now I'm going to update my current state because I know it now safely maps to the backing data in my event log. And if I instantiate it again, I'll be getting it back. So now I'm just setting my state back to the things that were in the event. And now I'm ready for the next thing. I'm only guaranteed to ever get one thing at a time. So between the time of my command coming in, my event coming in, and my state being updated, I'm getting no more calls to this piece of domain, this particular customer location. So there's no contention. And then from here on in, all we are is we'll remove customer location. We're a command handler for that. And we're an event handler for that. Activated device is going to add device to the collection. So it emits the event. Here it adds a device to our collection. Remove a device from the collection. It's event handler. And then finally, we have a signer and we have toggle nightlight. I'll show you that one. So toggle nightlight, this is where we side effect in the command. The problem with side effecting in the event is that events are subject to replay. So when you're instantiating again, you use the events to build up your current state. You wouldn't want to turn the light bulb on and off as you're reinstantiating. So the only good place to do it is really here in the command. So what I'll do here is I'll find the device. I'll emit the event. Did I just lie? Actually, I did. I just lied. I forget. We have a much better way of doing this now. And I'll show you that. I'm actually subscribing to the event log in another location. And from there, I'm flipping the bulb. Sorry about that, guys and ladies. All right. So that's it. That's your entire domain behavior for a digital twin IoT location that contains devices. And now you've got your core behavior of your system. Sorry about that. So from here on in, we've got some other things we support. One is publishing. So publishing to go PubSub. You can have another service subscribe to your messages that you're publishing. How do I accomplish that? I create a publishing service in Protobuf and GRPC, and I say, hey, I'm going to publish customer location added, and I'm subscribing to that that event that's being emitted, and I'm working that I'm using the eventing option in Akka Serverless, and the event source entity is that customer location entity that I've named, and then the out topic is going to be wireless mesh. In Google Pub Sub, if we were running on AWS, it would be something else. Maybe somewhere else it might be Kafka, but in this case, we're running on Google. And so I also would like to handle customer location removed. And then what I'm doing is I'm purposely saying that, hey, any other events, I'm purposely not handling them. I'd hate to have things go between the cracks and think I'm handling things that I'm not. So we purposely say, hey, I'm going to catch the other, and the system might log it or something like that. So that's event publication. The other one that's interesting is device control. So this is actually how we are now controlling this bulb. Is I'm subscribing to that eventing in, again, customer location entity. That shouldn't be there. And then I'm doing catch other. So this is my Protobuf portion of what I need to do here. And I also have a view that I've created in prototype. So I wanted to have a customer location by email request. So let's just say we have a sign-on process, and nobody's going to know their customer location ID per se, but everybody knows their email. So I'm maintaining a view here, and the view is built up by these events from the customer location entity, and I'm giving it an option of a view update, and I'm telling it the table will be customer locations, and I'll be transforming updates in Java with a little Pojo. And then I handle the get, and we have like a sort of query language to do this, where a get request comes in, and the data is sitting there in that view table, and I'm just doing a select star where the email matches the email. So you could look up your email, and then you could get your customer location that way. So those are my protobufs. And so now here is the Pojos that make them all really come to life. So the publishing action is really just a pass through. I'm doing a handler. I'm making sure the name is the same as I created in my Protobuf, publish customer location added, and I just simply return the event. So I'm publishing the event as is. If I wanted to clean it, sanitize it, transform it, or anything, this is where I would do it. And then the toggle nightlight action is doing send nightlight toggle. So I'm getting that nightlight toggled event. So this has been safely stored into the event log, and I know we're good to go. And what I'm going to do now is I'm just going to use whatever connection logic I need to connect to wherever I'm connecting. In this case, LIFX RESTfully, and I'm going to do that call to toggle a nightlight, and I'm done. So that's really it for the whole service, other than just the main function where everything starts and you're actually registering your stuff. So you're saying, hey, this is my event sourced entity. This is my view. Could have more than one view. These are my actions. I'm giving them their descriptors as well as the implementation class and the main. That's it. And that's really it. We're in business. We do a Maven clean install. There's project templates that actually spit out all that stuff for you for each language. So you get your whole structure for your Maven with the Docker stuff and all your dependencies, and it'll build your Docker image locally. You just tag it and you push it to Docker IO. I mean, you don't have to use Docker to the other things too, or Docker IO. You can use another registry. I've previously told Akka Serverless that that's my registry and this is my username. So from here, it's a matter of going into Akka Serverless, into my project. I've got a number of projects here for different things I'm doing right now. So if you'd like to see an example of like a whole system of these things, I'm working on something called Akachino, which is like coffee and IoT maintenance and stores and products and orders and stuff. You'll see that all that stuff is here. It's like pretty complex. Our example over here is a little bit more simple. All right, so services. is our wirelessmesh Java. So I've previously deployed this, and it's running fine on 2 pods. Never needs more than that. You can see different metrics: requests per second, failed requests per second, memory usage, storage attributes. Requests per second would be blind because I haven't been using it. You see your pods. You can see this is the image I last deployed. And if I wanted to redeploy, I typically deploy on a numeric value, so I can always go back in time if I like. So I would deploy number 201 if I went up to generation number 3 of this thing. And in that case, you get like a rolling update of your service, where the old nodes will be taken down and replaced by new nodes. And then your API methods are here published for you. So you can see that these are all the things you can do according to Protobuf. Once you start up the service, these all start to appear. And then logs. So if you've got any logging going on, I don't really have any logging in this one. This is where you'd see it. So this is really helpful for debugging. You can also do all this in the CLI and even get a little more logging information. So that's what it was. Services. So if I wanted to redeploy, I'd say redeploy service or delete. And in this case, I would bump it up to 201. You could set environmental variables. You have an option to turn on cores, yes or no, for your clients, to generate a new URL that points to your service. If you're redeploying, you wouldn't do that. You just use the same one. And just hit update. A few minutes later, your pods are replaced with new ones with that new Docker image. And that's as simple as the deployment process and the DevOps portion of it. So from here, I was going to hit the service and show you a little bit of its behavior. It's a good time if anybody does have any questions, or you can wait till the end. It's up to you. But I'll do a little pause just in case. Okay. All right, so I'm going to drop this down.
None yet. None yet, Sean. But yeah, folks, if you have questions for Sean, please, by all means, jump in the chat.
All right.
Sorry to interrupt, please.
This is now, am I ahead of time here? No, I'm good. So this is what I've done I've set up my location here. Make this a little bigger. So GRPC Curl is GRP Curl is an open source tool that makes it easy to make these GRPC calls. So rather than use Postman or something, I just use these. So I previously set up my location. So this add customer location, I called it Walsh 6000. I gave it the access token. I'm keeping that a secret because it's real. An email, I gave it a zip code. This is the name of the generated host I have for my service. I'm always going to be in 443, which is HTTPS. And this is my fully qualified name of my service and its method. So in my Protobuf, I have package wireless mesh. So that's prefacing, I have wireless mesh service, and then I've add customer location. So I've done that. Locations added. I could prove it to you by doing a GRPC curl. You can take a look at our location. And you'll see this looks very much like something you do in Postman with a RESTful call, where it looks a lot like JSON. So you get your customer location ID, your access token. In this case, I transform it in the get so it remains hidden. So you can be HIPAA compliant and stuff and things like that. All this stuff, here's my devices. I only have one device. It's this one here in my office, my pretend one in my office. And then I did a number of things where I was, let's see, I did activate device. Let's activate another device. Oops. Don't want to do that. Make sure I give it another device. Okay, I get return Google empty. So now I can just do a get and see that this happened. And so now you'll see I've got two devices, and I can assign this one to a room. I could toggle its nightlight if it had one, things like that. So this is the shocking part of the demo. Will be especially for me. It's kind of dark in here. I'll toggle that Nightlight. So I'll show you the GRPC Curl is customer location ID. It's got the unique device ID I assigned to this thing. It's got my URL and it's got my wireless service toggle Nightlight. And we'll do that. And hopefully if everything goes well, ta-da. Yes. I'll turn it off very quickly. And so this would be your developer experience of doing an IoT high scale, high throughput system with a digital twin. I mean, that's really just how easy it is. That's pretty much what I had to show you. And I'm definitely ready for some questions.
Awesome. Hey, thank you so much, Sean. Wow, that's wow. I love the fact that it's just like plain Java objects. You know, as you were showing, like that's super easy to get your head around, and like the lack, you know, the absolute lack of infra twiddling seems, you know, pretty powerful. That's really cool. Good stuff. Well, folks, we got Sean for a couple more minutes. We got some extra time. If there are no questions, we can always call it a little early, but would love to hear your thoughts and of course any questions for Sean. So please jump in. I can also unmute you if you prefer to verbal versus the chat window. Here, actually, we got a small group here. Maybe I can unmute all. Hold on one second. There you go. So you're welcome to just unmute and ask a question if you like. And you're welcome, Anand. Thank you. You're quite welcome. Let me see if I can unmute all with one command here. Just a second. Okay, I'm going to allow everyone to unmute themselves. So you should now be able to unmute yourself and ask. Let's test that real quick. Looks like that works. Okay, folks, any questions? Looks like we just had someone come into the waiting room. just in time for the end of the presentation.
Yeah.
Cool. All right. Well, Sean, while we're giving people a minute to formulate any thoughts, do you have any kind of like follow-up links, you know, things that you would want people to go check out if they're interested to learn more about this? How, you know, what's your sort of free tier or free trial sort of model that people can use to kick the tires on this? You mind talking to that for just a second?
So right now you can join the open beta. So that's the mechanism.
Oh, right. Sorry. You said you were still in beta. My apologies. Yeah. Yep. My bad.
And I will give you that link right now in chat.
Sure. Sounds good.
And so that landing page, the first thing you'll see is join the open beta. You'll learn a lot more about Akka Serverless, all of its capabilities and what makes it tick and things like that if you're interested.
Cool. The other thing that I thought was really interesting, Sean, is you know, something that DataStax has been doing too is sort of moving to an API first model, right? And like, hey, gRPC, right? You know, they support every language, so just get down with Protobufs and you know, you're good to go. You know, sure, you can always pop out something like REST if you have to, but you know, obviously gRPC is a little bit faster and also works over HTTP, so that's really cool. I've been seeing that model more and more lately from you know, various infrastructure providers, whether it's at the data layer or elsewhere. And yeah, I see kind of the cutting edge ones seem to be sort of focusing on that. Hey, how do I make this offering I have just show up as an API that somebody already knows? Like, yeah. So I've been seeing that a lot. DataStax is doing that too with our Astra Cloud and even in downloadable open source. So that's definitely a trend I'm seeing more and more often lately, and I think it's great for the developer audience of all walks, you know, because then you're not even dealing with specific drivers, right? It's just like, hey, it's gRPC, you know.
Everybody speaks it.
It's a lovely model. So, folks, what do you think? Let's hear from you. Not enough of me and Sean talking. Don't all jump at once, but if you'd like to comment or ask a question, this is a good time.
Are there any users of Akka out there? Or Akka cluster?
And you can just say something in the chat.
Yeah, you might recognize Akka Serverless. It's really it's just an abstraction of what really good developers are doing a lot of hard work to do in Akka Cluster itself, with all the DevOps and with all the expertise. And we've just tried to uplift it and make it available to the masses.